image. Okay, what is an image? See, when you stand in front of the mirror and see your face in the mirror, what we see is that the face which appears in the mirror is the picture. Okay, that picture is the image of the object. Okay, now there are two types of image: the real image and the virtual image. What is a real image? The image of an object formed by the real intersections of rays after reflection. Okay, that type of image form is known as the real image. Means the two rays comes from the object, and by some means or some device they come together and intersect at a point or meet at a point. That point where these two rays after reflections meet is the image of that object, and that image is called the real image. And real images are always inverted. For example, if let's say this is a candle, okay, now we'll represent this object by a simple drawing. Let's say this arrow is the object. Okay, so in case of real image, this object AB, when you see the image of this object, you will see upside down inverted, A dash B dash. Okay, so real images are always formed inverted in this way. Okay, this is the object, this is the image, and this real image can be caught on the screen. That means if you keep a screen where the image is formed, you will see the image is formed on the screen. It will appear on the screen and it will appear upside down. Okay, now let's come back to the virtual image. What are the virtual images? When the rays of the light actually do not meet but appears to be meet. For example, from an object, when these two rays goes parallel, okay, so it keeps on going and going and going. These two rays never come back and intersect, like in case of real. Okay, so in case of virtual, the rays from the object keep on going, but it will never come back and intersect. But what will happen at that point of time? The brain, okay, the brain will draw an imaginary line and will make the two line intersect. For example, this is an object A, B. If two rays diverge or goes parallel from this object, let's say this is the rays which are going from this object, okay, AB. So these two rays is never going to come back. It keep on going parallel. So when these two rays is not going to intersect, that means the image is not going to form. To form the image, these two rays has to come and meet again. But these two rays will never meet. Okay. So what will happen at this point of time when these real rays are not intersecting? Then what happened? The brain started doing its job. Okay. The brain will do some calculations and it will draw an imaginary line. So in real, the rays goes like that, but the brain will draw some imaginary line here and will make these two lines intersect. And this point of intersection here, the image of this object is formed. Okay. So this type of image formed by intersecting the imaginary line. But according to the definition here, when the rays of the light do not meet, okay, but appears to us to meet after reflection. So this type of image is known as the virtual image. Example, virtual image formed by the plane mirror, okay, is a example of a virtual image. I'll tell you how. And one more thing you need to remember is that in case of virtual image, the image is always standing. For example, A, this is the object A, B, the image also will be A dash, B dash, it will be standing like this, erect. Virtual image is always erect, real image is always inverted. And the real image can be seen on the screen or can be caught on the screen. If you keep the screen, it will appear on the screen. But in case of virtual image, if you keep a screen where these two imaginary lines intersect here, if you keep a screen here, this image of this object will not appear on the screen because it's not there, it's virtual. It's in reality, it's not there. But to us, it appears that it is formed there, image is formed there. Example of a plane mirror. Example is the image formed by the plane mirror. For example, just think yourself. No? If you are standing in front of the mirror, let's say here is a very big plane mirror. When you stand in front of the mirror, you see the picture of yourself in the mirror. That is the image of you. You are an object and the image is on the mirror. But if you take 2 or 3 steps behind, you will see that the object image in the mirror is also taking the 2 or 3 steps behind. So the image appear in the plane mirror is exactly the same distance you are from the mirror. The image is also formed exactly the same distance behind the mirror. But if in reality, if you go behind the mirror and try to see if there is any image behind, it's not there. But it appears to you that it is as far as you from the mirror, as far as the image from the mirror. But in reality, in behind, it's not there. But in case of real image, you see the image form on the wall, on the screen, and from the lights coming from the projector. In reality, if you keep the hand like that, the image will really form on the hand because it is there really. So that is the difference between the real image and the virtual image. Okay. Now our next topic is mirror. So there are 2 types of mirror. Okay. Here 2 types of mirror. First we have plane mirror, and then second we have spherical mirror. So in case if the question is asked in the exam, how many types of mirror do we have, or name the 2 types of mirror we have, you will not write concave mirror and the convex mirror, because concave and convex both form in the category of spherical mirror. So if it is asked only mirror, name the 2 types of mirror, then we have plane mirror and the spherical mirror. Okay. So this spherical mirror is again subdivided into 2. First we have is concave. Concave is a spherical mirror. And then we have convex mirror. Convex is also a spherical mirror. Okay. See the difference in the questions. Okay. Then the 2 types of mirror, then mirror and the spherical mirror. Then the 2 spherical mirror, concave mirror and the convex mirror. Okay. Now we have 2 types of mirror, plane mirror and the spherical mirror. We are going to study mainly on the concave and the convex mirror. So some of the properties, I'll just give you properties formed by the of image formed by the plane mirror. Okay, and then we'll directly go to the spherical mirror. So in just a few minutes back, I told you that the plane mirror forms an image which is virtual image, right? So this some of the properties of image formed by plane mirror. These things you need to remember. Okay. In the exams, it might ask for 1 mark. Number 1 property. Okay. Image is virtual. And virtual image is always standing, which we call it virtual and erect. Second point is object distance. Is always equal to the image distance. As I told you in the earlier, if you take 2 steps behind, the image is also going to take 2 steps behind, which appears that the object distance and image distance is equal. Third thing is image appears in the plane mirror is laterally inverted. Laterally inverted. What is laterally inverted? Laterally inverted means the right hand, left hand change of the object and image. Okay, if I am standing in front of the mirror, I am seeing myself in the mirror, that the face of mine in the mirror, that is the image, I am the object. Now if I lift my right hand, the image in the mirror is going to lift the hand which is on the same side of me, this side. But if I see from the image perspective, okay, then the image is lifting the left hand, but the object is lifting the right hand. So the right hand of the object becomes the left hand of the image. So this left hand right hand change of the object in the image is called the laterally inverted. Now we will start with the concave mirror. Now, what is a concave mirror? Okay, definition is very simple. A mirror whose reflecting surface is inside the curve. Okay, that type of mirror is known as the concave mirror. See here. For example, this is a curve. Okay, a mirror whose reflecting surface. So reflecting surface is the glass part, the plane part, glass part. So this is the reflecting surface inside the curve. So this is a curve and this is inside. So the reflecting surface is inside this curve, and the back part is the color with silver, which will protect the light from passing through. If the light will not pass through, then it will reflect, right? So it is color with silver here behind. So inside is the reflecting surface. So a mirror whose reflecting surface is inside the curve is known as the concave mirror. Okay, let's say this is M has M has. Convex mirror. Convex mirror. Same definition, a little bit change here. A mirror whose reflecting surface is outside the curve. So this is the curve. Okay. So this is inside curve, this is outside curve. So it means the glass part, the reflecting surface is outside. Inside is protected with silver so that the light will not pass through. So we have mirror M and M dash. Can you see the difference between these two? Concave mirror which has a reflecting surface inside, convex mirror which has a reflecting surface outside. Definition is as simple as a very short sentence, right? So this is the type of the spherical mirror we have, concave mirror and the convex. Let's start with this, okay? Now, the parts of the concave of the mirror. So the mirror M and M has exactly the center of this mirror. There is a, it's called the pole. Okay, the center of the convex mirror is called the pole. Okay, so there is a straight line which is drawn from the pole, and this straight line is known as the principal axis. Principal axis. These are the parts of the mirror. So for the concave mirror, convex mirror, it is extended. Okay, this is the pole, this is the principal axis. Okay, this is called C, center of curvature. Center of curvature. This is known, these are the parts of the mirror, okay, which we are going to learn. Here, the center of curvature, C. Now, in a concave mirror, the center of the curvature is inside the, in front of the mirror. This is a mirror, okay. But in a convex mirror, the center of curvature is outside the, behind the mirror. This side is mirror, this side is behind the mirror. So the center of curvature is behind the mirror, okay, here. But in concave, it is in front of the mirror. Okay. Now, between the center and on the pole of the mirror, right at the center here there is a focus. Right here is the focus. So for convex mirror on the other side also we have focus and the center of curvature. It is extended this way. Okay. So these are some parts of the mirror. Okay. These are the some parts of the mirror. We have center of curvature, we have focus, we have pole. Exactly same here in the convex mirror also, center of curvature, focus, pole, focus, center of curvature. Okay. Now, why this is called center of curvature? Why this is called focus? How is a concave mirror constructed? Means how a concave mirror is made. We already know the meaning of this word spherical. Means in other way, the spherical means round. You have seen a tennis ball which is round in shape. Globe of the earth, a football, basketball which are round in shape. Right? Let's take an example of a tennis ball. If you cut it into half, how does it appear? Like a curve like this, right? If you take the half of the cut part, half of the tennis ball, it will appear something like this curve, right? Like this curve. So if this curve was a complete spherical, if this curve was a complete spherical, means if it was a complete circle, round, then when we draw a circle, we start from the center of the circle, the point, and then we draw the circle, right? So the center of the circle, right, like this, right? With the help of the compass, we first take the point where that point becomes the center of the circle and we draw the circle. Same like that, a spherical is also a round which has a center, right? Now this point, center of the circle, here it is called center of the circle, but here it is called the center of the curvature because it's not a circle but it's a curvature. It is a spherical round surface. So the center of this spherical object, right, that center is called the center of the curvature. Okay. Now the distance from this center of the circle to the circumference, this boundary of the circle, we call it the radius of a circle. If you compare this one here, from the center of this spherical hollow to the boundary of this mirror, okay, up to the pole, is called the radius of curvature. We do not say radius of a circle because this is not a circle but this is a spherical round shape. Okay. So the distance from the C to the pole is called the radius of curvature. The distance from the C to the circumference of a circle is the radius of a circle. But we don't have radius circle here. We have a spherical round shape. So we call it, it's a radius of a curvature. Okay. Now the distance from this focus to the distance up to the pole, okay, this short distance from the focus to the pole is called the focal length of the mirror. The focal length, okay, the distance from the focus to the pole of the mirror is called as the focal length. So this is the focal length of this mirror. Now the focal length of this mirror, the distance from F to P is, let's say, 5 centimeter. Then the distance from the F to C is known as the 5 centimeter. Is also 5 centimeter. That means from C to P exactly divided by the F, equally divided. So the same distance here is the same distance. Now how the focus comes here? The focus comes here because if a light ray parallel to this principal axis, it goes like that. When it hits this mirror, after reflection, it's going to intersect at this principal axis at this point. So another light ray comes parallel, hits this mirror. After reflection, it intersects at the same point where the first ray intersect, second ray. So let's say another ray come parallel to the principal axis. After reflection, it also pass through the same point. This is the third ray. Another ray comes here parallel. After reflection, this fourth ray also goes through this same point. So this points where all the parallel ray intersect is called the focus. Focus means focusing, right? Concentrating at one point is called focus. Okay. So this all the parallel rays in the principal axis after reflecting all concentrate at one point, means all are focusing at one point. That's why this point is called focus, and this point is exactly divide the center of curvature equally here. So sometimes it is called C is also called twice F because it is the same distance here. So 2 times the focal length is the radius of the curvature. Okay. Now the point here is as long as the rays are parallel to the principal axis, the light ray is going to pass through the focus. That's how the focus is formed here. Okay. Now I hope you will remember all the points of all the parts of the mirror. Let's recap here. This is a concave mirror, and the parts of the mirror are, there's a pole right in the center of this mirror, and then there is a straight line which passes through, we call it principal axis, and then there is a center of curvature, there is a focus. Okay, so these are the parts of the mirror that you need to remember.